not half of the students are present. Okay, so let's begin the discussion. So in the previous class, we discussed about the separable ODE. So what we are going to do in this class is, let's first solve some problem that are separable ODE but initial value problem. Okay, and then after that we will look into some application oriented problem on separable ODE. That means what are the real life problems that could be solved using separable ODE. So let's discuss that one. Okay, so the first one is some initial value problem on separable ODEs. Right. So it's pretty much similar problem that we discussed in the previous class. Only the difference here is that with the ODE, a initial condition will be provided, and you need to solve that one. So if we begin with this one, let's say question number 1 is x y dash plus y is equal to 0, and the initial condition is y4 is equal to 6. So the first one is the ODE that we need to solve, and we need to find out the generic solution or generalized solution. Then we can use this initial condition in the same solution to find out the specific solution. So that is our job, right? So if we try to solve the general solution, general ODE for the generic solution, how we should proceed? We should proceed with just solving this one, that is our x. This is dy by dx is equal to minus y. This is the ODE, right? So what we need to do is that apply the separable method. That means we take all the y one side, all the x to the other side. Then it will become dy by y is equal to dx by x. So it should be a negative one, right? And that's the thing. Then we just integrate both the sides. If I will integrate both the sides here, what I will get? I will get ln y is equal to minus ln x plus c. Right? Then what is the y here? Y is equal to how much? I can write c e to the power ln x inverse. That means that will give me c by x. Can I write this one? Is this okay? Or any confusion? ln y, if you take keep y, that it will be e to the power something, right? I just apply that method, right? So I got the solution, that is y is equal to c by x. This is my general solution, right? And what I need to do, I need to apply the initial condition. So those two screens are on, okay. So initial condition is, what is the initial condition? y4 is equal to 6. That implies when x is equal to 4, y is equal to 6. This is what the initial condition is. So we need to put these conditions here. That means if we put, we will get 6 is equal to c by 4. That implies your c is equal to 24. Then your specific solution, or you can say the particular solution, which will be more appropriate term, particular solution, y is equal to 24 pi x. Okay. Moving on to the next one. Maybe the next question is question number 2. Y dash is equal to 1 plus y square, and the initial condition is y1 is equal to 0. Can you solve it? Yes. How? This is dy by dx is equal to 1 plus y square, implies dy by 1 plus y square is equal to dx. If I will integrate both sides, I will get how much? ln, no, not ln, arctan or tan inverse y is equal to x plus c. Yes. Then what is my y? My y is equal to tan x plus c. This is the general solution. Yes. Now the particular solution. What is my condition? The initial condition. y1 is equal to 0. That implies when x is equal to 1, y is equal to 0. Right? I just need to put these values in the solution, general solution. So if I put these values here, then it will be 0 is equal to tan 1 plus c. Right? Then what is the value here? I can put 1 plus c is equal to how much? Tan inverse 0. What is that? What is the tan inverse 0? Yeah. Yes. 0. Anything else? No? Are you sure? Yes. Pi. Pi is also tan pi also 0. Tan 0 0, tan pi 0, tan 2 pi 0. 2 pi also 0. So you can put any value here. This 0 or pi, 2 pi, whatever value. Up to you can take n pi, any value. Let's say if you take n pi, that means when n equal to 0, it is 0, 1 pi, 2 pi, 3 pi, n pi. So to be more secure answer will be n pi, where n could be 0, 1, 2, 3, any number. Right. So let's say it is n pi. Also you can write 0, but the objective is to get the particular solution. But it is more advisable to write n pi than writing 0. Right. So if it is n pi, then what is my c? Minus 1 plus n pi. Okay? If this is my c, then what is my particular solution? My particular solution is y is equal to tan x, yeah, minus 1 plus n pi. Yes. Is it making sense? That means I can rewrite this one as simply tan x minus 1
I can drop n pi, it's ultimately becoming 0. That means writing the solution as 0 is also giving us the same solution. Right, you can write 0, you can write n pi. Right? Yeah. Okay? Okay, so let's move on to the next question. Y dash is equal to x plus y minus 2 whole square and y0 is equal to 2, the initial condition. How to solve this one? So to solve this one, this one looks a little tricky. So it is y dash is equal to x plus y minus 2 whole square. So what we can do is, let's assume, let x plus y minus 2 is equal to m. That implies your y is equal to m minus x plus 2. Yes. Then what is your dy by dx? What is your dy by dx? dm by dx minus 1, right? So let's put these values. Which value? Oh, sorry. This value and this value. Yeah. That means I can rewrite this one as y dash, that is dy by dx become, so I can write this one as I can write this one, this is dy by dx, so I can write this one as dm by dx minus 1 is equal to m square, or you can simply write dm by dx is equal to m square plus 1, and then apply the separable method. dm by m square plus 1 is equal to dx. Okay? Here apply the integration, and when you apply the integration, what will you get? Right? That means your m is equal to tan x plus c. But m is not your answer. Your answer is x plus y minus 2 is equal to tan x plus c. Or you can write your y is equal to tan x plus c minus x plus 2. So this is your general solution. Okay? Yeah, if you have any confusion, you can ask me. Now you have to put the initial values. What is the initial value? The initial value here is y0 is equal to 2. That means x is equal to 0, y is equal to 2. So we can now rewrite the problem by putting this value. 2 is equal to tan 0 plus c minus x plus 2. Oh, sorry, this one is supposed to be 0. That means you are getting tan c is equal to 0. That means you can calculate your c is equal to 0.2. Then your final answer, specific or particular value, y is equal to tan x minus x plus 2. Okay. Okay, so we saw some problems using initial value. There are many problems are there. I will try to give some flavor of different types of initial values problem. So let's move on to some application oriented separable ODE. Okay, that means here we will see some real problems, day-to-day life problems, and how we can use the ODE to solve them. Okay, so carefully observe these problems. So let me write down the problems one by one, then we can solve. Okay. So this one is in the category of, you can say, exponential growth. Here is the question, so carefully write. If the growth rate if the growth rate of the number of bacteria at any time t is proportional to the number and doubles in 1 week. How many bacteria can be expected after 2 weeks? And 4 weeks. Oh, sorry for my very bad handwriting. You have to adjust with that one. Yeah, that's a habit of from my childhood. I'm not very good in writing. And after becoming a teacher, I stopped writing in pen and paper. Yeah, I'm very much good in writing on the board, not using pen and paper. Okay. First write it down and read it one completely. Then we will discuss. If the growth rate of the number of bacteria at any time t is proportional to the number present at t and doubles in 1 week, how many bacteria can be expected after 2 weeks and 4 weeks? Some important observation you need to understand here. Yeah. Some important observation is that it is mentioned something called growth rate. And what it is saying, growth rate of the number of bacteria at any time t is proportional to the number of bacteria at present. Okay. Here derivative is not with respect to x, with respect to t, because in general in mathematics we always consider x, the changes with respect to x. Here the variable is changed to t, time. Okay. So the first thing we need to understand that number of bacteria, let's say that number of bacteria is y. Y is the number of bacteria, right? And what is saying growth rate? What do you mean by the growth rate? The change in the number of bacteria, right? So if I will write that one is y dash, is this okay? If y is the number of bacteria and y dash is the change in the number of bacteria, growth rate, y dash. And what it is saying that the growth rate of the number of bacteria at any time t is proportional to the number present at t. That means if this is the growth rate and this is the number of bacteria at time t, I can simply write this. What is this? Proportional. You don't know this symbol? You don't know this symbol? Really? Proportional. What do you mean by the proportional? This one is proportional to this. If this one increases, this one increases. If this one decreases, this one decreases. Come on. You are engineers. Is this okay? The growth rate of the bacteria is proportional to the number of bacteria at present. That means I can write this is dy by dt. I am not writing dy by dx. I am writing dy by dt because time is the variable here. Dy by dt is proportional to y, that implies dy by dt is equal to k y, where k is the constant. K is any constant. Yes or no? If this one is proportional to this, then how we can equate them? With some constant. If y dash is proportional to y, then y dash is equal to some constant into y. That is how we equate when they are proportional to each other, right? So I can write this one dy by dt is equal to ky, and now I can apply this separable method here. On this I am applying the separable method. That means I can write dy by y is equal to k dt. I will integrate, and that is giving me ln y is equal to kt plus c, and that is giving me y is equal to c e to the power kt. This is my general solution. Yes. Now, if you have any confusion, you can ask me. Now, if you look into the question again, there is some initial condition provided. Yes or no? Please go through the question. What is the initial condition and tell me. What is the initial condition? Yes. You read the question, it is clearly written there. Yes? That's the point. Very good. That means in 1 week the number of bacteria get double. That is the initial condition. That means I can redefine this one like this. Let's say at t is equal to 0, I can write y is equal to y0. Assume. Okay? Then at t is equal to 7, y is equal to 2y0, right? And what I am supposed to calculate is t is equal to, when t is equal to 14, 2 weeks means 14 days. Then what is my y? And when t is equal to 28, what is my y? So this is what is the initial condition given, and I want, this is the question, this is the answer I am looking for. This is the initial condition. So what I need to do is that I need to put those initial conditions here. Now, so let's say I put, this one is my condition. Let's say I will put this one is my equation 1 and equation 2. Okay? And this is my general solution. Okay? So now let's put equation 1 in the general solution first. What will I get? Y0 is equal to C e to the power k0, and that is giving me C is equal to y0 Yes. Now putting all these values back, that means this C value and equation 2 and this 2 values back in the original problem or general solution. It will be 2y0 is equal to C is y0 and e to the power k 7. Putting equation 2 and this one, let's say equation 3. Okay, I can write here. Okay, so by putting this I can get 2 is equal to e to the power k 7, and solving this I will get the value of k, that is ln2 by 7. Yes. Now I have ln2 k value, I have c value, I have t value, I have. I can find out the y, because you have one question. Question 1 is if when t is equal to 14, what is the y? Question 2 is when t is equal to 28, what is the y? I just need to put these values to find out the y's. Okay. Okay, so then let's move on to the next one, which is coming under the category population model. Okay, so let's write down the question first. If the birth rate and death rate of the number of bacteria are proportional to the number of bacteria at present, what is the population as a function of time? Read the question carefully. First thing, there are two information is given. One is the birth rate. If the birth rate and the death rate of the number of bacteria okay, we'll take a break, then we'll discuss. Once you-
要买哪一锅？哪一锅？知道。泡在后面睡着。我开始一会儿睡觉。
Okay, so let's continue. So what is the population model problem is that if the birth rate and the death rate of the number of bacteria are proportional to the number of bacteria at present, what is the population is a function of time. Two things you need to understand here. First, as I mentioned, let's assume the population of the bacteria is Y. Y is the population of bacteria. So here I have provided two information. One is the birth rate, another one is the death rate. If I write this is the birth rate and this is the death rate. Okay, so it is saying that the birth rate is proportional to the population and the death rate is also proportional to the population. Y dash So it is saying that the birth rate and the death rate both are proportional to the population of the bacteria. So if Y is the population of the bacteria, so I am taking birth rate and the death rate. So you can ask why I am taking two different things as Y dash, Y dash. So it is saying the variable is one with respect to time, whether it is birth rate or the death rate, it is changing over the same time, right? That's why I'm writing this is Y dash proportional to Y and Y dash proportional to Y. The birth rate is proportional to the number of bacteria as well as the death rate is proportional to the number of bacteria. Is it making sense? Then how I can differentiate, how I can distinguish what is the birth rate, what is the death rate? I can do that only when I will try to equate them. What is that? That means I can rewrite this one as dy by dt is equal to, let's say, some constant k1 y, and this one dy by dt is equal to another constant, let's say k2 y. So this is how I can differentiate what is the birth and what is the death. Is it okay? Then the question is, because birth rate is increasing the population, death rate is decreasing the population. So what I am looking for? Whether the total population is increasing or decreasing, that is the growth rate. If it is increasing, positive growth. If it is decreasing, negative growth. Right? So I can rewrite this one as the growth rate dy by dt is equal to k1 minus k2 yes. Then I apply the separable method, that implies dy by y is equal to k1 minus k2 dt, and I can apply the integration here, and by applying integration I will get ln y is equal to k1 minus k2 t plus constant c, that is giving me the y is equal to c e to the power k1 minus k2 t. You can see the population growth with respect to time, population growth function with respect to time. Yes. There is any initial condition, then we can also put that one to find out the value of C. Okay, that is secondary now. Okay? Any confusion? Okay, so let's try another question. This is a question based on dryer. Dryer, you understand? The washing machine, we dry our clothes. We wash our clothes in the machine. You understand that one? So I'm talking about that one, dryer. We dry our clothes. If a wet sheet in a dryer loses its moisture at a rate proportional to its moisture content and if it losses half of its moisture during the first minutes of drying, when will it practically dry? That can say when will it have lost 99% of its moisture. believe all of you can understand what I am writing. A wet sheet, you understand what is wet sheet? Whatever your wet cloths, okay? Maybe bed cover, whatever, okay? So you want to wash it. After washing, you want to dry it. So you put it in the dryer. It is completely wet, and you turn on the machine. After you turn on the machine, after 10 minutes, 50% of the water is drained out from your clothes. That means your 50% your cloth is dry. Okay. Now it's asking the question that how much time it take to make your cloth completely dry. Okay. So when you say the completely dry means it should be 99% dry. Complete dry means 99% of the moisture will be dry out. Okay, that is the question. And how much time it takes. I believe I clarify you the question clearly. Okay. Okay, so let's move on. How exactly we can proceed to solve this one? So if I try to write down it in this way, it is mentioning a time t0. Okay, when time t is equal to 0, moisture in your wet sheet, let's say y is equal to y0. Okay, and at time t is equal to 10, that means after 10 minutes moisture become half, right? 50% will be drained out. So your y is equal to y0 by 2. And then the question is that when your t is what is the time t? We need to find out when your y is equal to 0.01 y0. So y0 is the value that we are considering at initial point, how much moisture is actually in your wet sheet. Right. So this is the given information for us, and this is what we want to calculate. Previous questions we tried to find out the growth function or the function y. Here we are not interested in that. That one is given. We are interested to find out the time instead. Okay. So as usual, if you look into this problem, one is the moisture content given. Let's say moisture content is y. Okay. And rate at which the moisture content losses. What is its rate? It is a rate proportional to the moisture content. Moisture dry, the wet sheet in a dryer loses its moisture. That is the loss of moisture from the dry sheet. That we can consider at a particular rate it is getting dry. Y dash. So y dash is the change in the moisture in the dry sheet, and y is the moisture rate. Okay. So we can clearly write this one is y dash is proportional to y, right? That implies, it is making my job easy, dy by dt is proportional, or I can say some constant k y, and that is making my job more easy by applying the separable method. Dy by y is equal to k dt, and here I am applying the integration. So that is giving me ln y is equal to kt plus c, and then my y is equal to c e to the power kt. After solving this OD, I got this information. Right. Okay. Now, if you notice here, when we are interested to solve this one, so this is one constant. We should need to find out that this is another constant. Two unknown constants are there. We need to solve them, right? Let's number this equation. Let's say this is 1, this is 2, this is 3, and this is 4. Let's put 1 in 3. That is giving us how much? y0 is equal to c e to the power k0. That is giving us c is equal to y0, which is my, let's say, 5. I just number the equations 1, 2, 3, 4, and 5. I just put the value of 1 in 3. Sorry, in 4. In 4. I can write it. Yeah. Then put 2 in 4, 2 and 5. 2 and 5 in 4. Then it is y0 by 2 is equal to y0 into e to the power k10. So this will give us how much? This is 1 by 2 is equal to e to the power k into 10, and if you solve this one you will get k is equal to ln 1 by 2 by 10. Let's say this is 6. Okay. Now put 3, 5 and 6 in 4. It is 0.01 y0 is equal to y0 into e to the power ln 1 by 2 by 10 t. To solve this one, it is 1 by 100 is equal to e to the power ln 1 by 2 by 100, sorry, 10 into t, and to solve this t, this is 10 into something like this. Any confusion? If I break this one, it will be ln 1 over 100. This side will be how much? ln 1 over 10 by 10. This ln 1 by 2 by 10. So I try to calculate t from there. break the ln, it will be e to the power something. When you remove e, it will be ln something. Yes or no? If you break, something is given like let's say it is given ln y is equal to let's say cx, something like this given, then y is equal to e to the power cx, right? So what I am doing, I am just going to calculate this one. Your confusion is here. Your confusion is here. If I'll break this one, I'll just put this one. ln 1 by 2 by 10 t is equal to ln 1 by 100. That implies that t is equal to ln 1 by 100 by ln 1 by 2 into 10. If I calculate this one, it will be 6.64 into 10, that is 66.4 minutes. Now don't ask me how I am getting this value. You have calculator to do that one. You can use, as I mentioned before, you can use calculator. Right. Okay. So let's try one more, then we'll move to the next part. Should we move to the next one? So these are some examples that when we have some real life physical problem, how we can apply engineering mathematics to solve them. Okay. Okay, so the next one, this one is based on very popular one, Newton's law of cooling. Newton's law of cooling. We apply Newton's law to cool something. Okay, so let's understand this question first.
A thermometer whose reading is 5 degrees centigrade is brought into a room whose temperature is 22 degrees. Right. One minute later, the thermometer reading is 12 degrees centigrade. How long does it take until the reading is practically 21.9 degree centigrade. All of you can understand what is a thermometer, but not the one we click in the electronic nowadays. The real traditional thermometer that we put in the mouth or ear to measure temperature when we have fever. So what is saying that normally initially the thermometer reading is 5 degree. Okay. So when we bring it to little bit hot weather, the hot area, its temperature will keep on increasing. Okay. So it is saying that the room temperature is 22 degree and the thermometer reading is currently 5 degree. So when we bring it to the room temperature and place it, it's saying that after 1 minute the 5 degree become 22 degree, 12 degree, and it is saying since the room temperature is 22 degree, so it will accordingly the thermometer temperature will keep on increasing. So it is asking how long does it take this temperature of the thermometer become this. So again here we need to find out the time. From initial temperature is 5 degree and after 1 minute it become 12 degree, and how much time it will take to become 21.9 degree, and the room temperature is given 22 degree. Okay, all of you clear? Okay. So few point we must note down. As I mentioned, at time t is equal to 0, the temperature is 5. Right. Okay. At time t is equal to 1, the temperature become 12. And the next one is what should be the time we should calculate. The temperature will become 21.9. So this is what we need to calculate.
What else is given? The room temperature. Let's say the room temperature, that is, let's say T0 is equal to 22. Okay, so it is saying dt by dt, T for the temperature, reading temperature, dt with respect to time. Okay, capital T we are using for temperature, small t we are using for time. Okay, don't get confused. So it is saying is proportional to the change in the temperature, that is T minus T0. So this T, this one is the temperature reading and this T is the room temperature. Okay, that means I can write dt by t, dt by dt is equal to t minus t0 into some constant k. That implies dt by t minus t0 is equal to, I am applying the separable method, k dt. I am applying the integration here. So when I am applying the integration, I will get how much? ln t minus t0 is equal to kt plus c. That means I can rewrite this one, t minus t0 is equal to e to the power kt plus c, or I can simply rewrite this one, c e to the power kt. Now the point is, what is, so I can write now t is equal to t0 plus c e to the power kt. Then what is my c? Sorry, what is my t0? What is my t0? 22, the room temperature. I can put that value directly. So then my t is nothing but 22 plus c e to the power kt. Now I have two more initial conditions. What are those? One is this one, another one is this one. One is when t is equal to 0, when t is equal to 0, t is equal to 5. Another one is when t is equal to 1, t is equal to 12. Right? So let's first put this one in this equation. So I can rewrite this one as t is equal to 5, that is 5 is equal to 22 plus c e to the power k into 0. So solving this one, it is giving me c is equal to how much? How much? Minus 17. So I found this is another value. Right? So now the next step, I will put this value and this value into the same problem again. Then I can rewrite this one as 12 is equal to 22 plus minus 17, okay, e to the power k into 1. That means this one is giving me e to the power k is equal to 10 by 17. That means my k is nothing but ln 10 by 17. Is this okay? Now you have all the information. What is C, what is K, all the information, and the T is D you have to find out. The small t, 5, the capital T is given. That means when your T is equal to, question is when T is equal to 21.9, what is your T? This is the question you need to find out. You need to answer. That means putting all this value in the same equation, that means 21.9 is equal to 22 plus minus 17 into e to the power e to the power ln 10 by 17 into t. This is minus 0.0 how much? 1 is equal to minus 17 into e to the power ln 10 by 17 into t. Yeah, you can solve it. What is the t? Approximately what I got is 6-7 minutes. Okay. So this is the end of separable OD, and we will discuss about exact OD, that is the different types of OD in the next class. See you guys in the next class.